So sometimes when we have a system of linear equations, it's not as nice to graph to find the solution because we could get fractions, decimals, or maybe the numbers are just larger or we don't have graph paper handy. So when that happens, we want to have an alternative, so solving algebraically. And the first one we're going to be going over is how to solve using what's called substitution. And we all know substituting means we're replacing something for another, right? And we're used to substituting a number in for a variable. But in this case, what we're going to do is we're going to substitute an expression in for the variable. So you can pick whichever variable you want to, isolate, and then we're going to plug it in to where the variable is in the second equation. I think this will be a little bit easier to understand when you actually watch me do the example. So let's take a look at example A. And what I want to do is I want to see, well, first, is there a variable all by itself? And look, what do you know? Y is all by itself, and y is equal to x, negative x plus 3. So what the substitution says is, hey, why don't we take out the y in the second equation and replace it with that expression, negative x plus 3? Because what happens then is I lose all the y's in my problem, and then I can just solve for x. So what I'm going to do is literally take out the y and plug in that negative x plus 3. Okay, and then leave everything else the same in that second equation. And now this looks like something we can solve from the beginning of the year. And again, you had to make sure the y was by itself to do that. Okay? And you don't always have to do y. It could be x as well. But we're just going to go ahead and solve like we did back in Unit 1, Chapter 1. Right? Combine your like terms. Completely isolate the x to get x equals negative 5. And remember, our solution should be where the two lines intersect. So don't just stop with the x, but now let's go ahead and figure out the y value. And we can use that first equation, since y is already all by itself, to solve for y. So once I know x is negative 5, I'm going to go ahead and plug it in to find y. So it's the negative of negative 5 plus 3. Right? So it's going to be positive 5 plus 3, which is 8. So my solution should be the point, negative 5, 8. And that's how substitution works. Okay? So if you take a look at B, still same thing, right? Two equations, we want to find our single point of intersection. And if you look now, I don't have a y equals or an x equals. So you might be thinking, well, I can't do this. But you actually can. Just take one equation, and the top one's actually nice and easy to use, and either solve for x or y. It doesn't matter which. Since it's really easy to get x by itself, I'm going to go ahead and add y to both sides and say x equals y plus 4. And now I have what x equals, and I'm going to go ahead and replace it for the x right there. And that is still substitution, so it doesn't always have to be y, it can be x as well. So it just depends on whatever you feel like you can solve for really easily. So I'm going to go ahead and do that substitution. So 2 times, and then plugging in what I get for x, y plus 4, plus y equals 4. And again, just distributing and solving like we are very familiar with. Okay. Let me scoot that up just a little bit. So I'm going to get y equals negative 4. Okay. And I want to go ahead and solve for x. And it doesn't matter which equation you use. You can always go back to the original. You can use the one that you solve for. I personally like to go back to the original just to make sure I'm not, using an equation that might have ended up being incorrect. So I'm going to go ahead and use that top equation. So minus negative 4 here equals 4. X plus 4 equals 4. So then x is equal to 0. Right? So my point should be 0, comma, negative 4. So I got my solutions, and I should be pretty confident. Now, if you're not 100% sure if this is correct, remember, you can always check, like we did in the last notes. So let me show you right over here. So I'm going to scoot my paper over. if I want to check, it's just like we did in the last lesson. Take your point, plug it into both equations, and it should work for both. So 0 minus -4 should equal 4. 4 equals 4. Beautiful. 2 times 0 plus 4 should equal 4. 4 equals 4. Perfect. So now I can be super confident this is the correct answer. And this is something I would encourage you guys to do in your homework or in your just to practice that, and definitely on your tests and quizzes, just to make sure you get the right answer if you have some extra time. Okay? And that's really all we're going to talk about in today's video. So I'd like you to go ahead and try out 1, 2, 3, and 4. Okay? Just a quick note here for number 1. You might be thinking, wait, I have 2 y equals, what do I do? Just take one of the y's, plug it in for the other. So let me start you off here. So I'll take out the y on the bottom and replace it with 3x plus 14 and make that equal to -4x. Okay? So go for it and let's see what we get. Alright, go ahead and check your work. So hopefully you saw with number 2, it was really simple to plug in that 1/2 x minus 1 for y. Alright, remember you are always substituting back into the other equations. You always want to make sure you're using both equations. So check your answers here. If you need a pause to jot down any of my work, feel free to do that. But let's also scroll down and take a look at 3 and 4. So with 3 and 4, you actually needed to substitute in, solve first for either x or y, and it doesn't matter which one you use. So you don't have to have the exact same work as me, right? For number 3, I used the second equation and solved for x, and then plugged it into the first one. For number 4, I solved for x in the first equation and plugged in the bottom one. So it doesn't matter if you solve for y or solve for x, you should end up with the same final answer as me, and that's what's the most important piece. So make sure, again, you're feeling okay with your fractions. It all depends on the type of problem that we get, all right? And let's make sure you come back to class with questions, because we're going to do the last example on the word problem together. All right? Thanks for listening.